All right, guys. So this is going to be page 77. Your review, put it in your binder. That's going to be page 76, okay? Now, the second half of the unit is polynomials. Intro to polynomials. A polynomial is an expression. Who remembers the difference between an expression and an equation? Equation has an equal sign, okay? A polynomial can include constants, variables, and whole number exponents. Now, very, very, very important, a polynomial cannot not include division by a variable. Meaning, if you have a fraction, you can't have a variable in the denominator. No letters. Okay?
No letters, numbers.
No, I don't know.
Yes. Yes, only numbers.
No.
All right, so based on the definition above, state whether or not the following represent polynomials. Justify your thinking. So, look at A. Would this be considered a polynomial, yes or no? Think about what we just tested over, what we just quizzed over. No. Why not?
Because it's an answer, not
Look at that last. Look at this last. Hey, focus. 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 What does that last rule say? Cannot include division by a variable. Now look at example A.
Oh, it's negative.
When you have a negative exponent, what happens?
Divide.
You move that to the what? Bottom. And if it moves to the bottom, what ends up happening? It becomes a fraction, and you have an variable on the denominator, and that you cannot divide by a variable. Focus, guys. All right, look at example B. Is B a polynomial, yes or no? Not because it has a fraction. The variable's at the bottom of the fraction. It can have a fraction as long as there's no variable at the bottom, but this one has a variable at the bottom. So, same rule. Or same excuse. C, is that a polynomial, yes or no?
Yes, because it doesn't have a fraction with a variable at the bottom and the exponent is a negative.
Correct. What about D?
Yes.
Yes.
Yeah.
What about E?
Yes.
Yeah. Even though it's a fraction, there's no variable at the bottom, so this one is a okay. And last, what about F?
No, because of the variable.
You have a variable in the denominator. Brantley, please chill out. All right. So, degree of the polynomial. The degree of a polynomial is going to be the largest exponent in the expression. Okay, largest exponent of any term in the polynomial. Now, to write this in standard form, you will have to write your terms in descending order based on the degree of the term. Meaning you would write it as x to the fourth, then x cubed, then x squared, then x, blah, 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 so forth. In this form, the coefficient of the first term is called the leading coefficient. So based on those definitions, we're going to label the parts of this polynomial. The very first arrow is pointing to the 3. This 3 is the very first coefficient in the whole expression, so that makes it your leading coefficient. This arrow up here is pointing to the 2, my exponent of 2, which is now called my what? The degree. Okay. Now the 4x has an exponent of 1, but your degree is always going to be the highest exponent, and the higher exponent is 2. Now 7, the arrow pointing to the 7 is a vocabulary word that we should have learned in the very beginning of the year. Any number that's by itself is called a what? Constant. Okay? And last but not least, each group of numbers and letters or numbers by themselves are separated by plus and minus signs. So we have 3 separate groups here. Each one of those groups is called a what? Term. They're my terms. Okay? So for number 1 and 2, what they want us to do is rewrite each of the polynomials in standard form. Remember, to write in standard form, you're going to write your terms in descending order with the highest exponent first. So if you look at number 1, which term has the highest exponent? So 4x to the power of 5. Then what comes next?
7x to the power of 2.
7x to the power of 2, and then 15. Okay? Your degree is only the highest exponent. What is my highest exponent?
4x.
So the highest exponent is 5. The degree is 5. Got it? Number 2. That's not all there is to this assignment. Number 2. What is the highest exponent in the expression? The term with the highest exponent is 2x to the power of 4. Then what would come next?
5x.
Now, 5x cubed is what type of number? Is it positive or negative? So we connect it with the plus sign. What comes next? Minus 10x. And then? Minus 13. Now, the degree is my highest exponent, which is 4. Now, all of the expressions that you're going to be working with today are polynomials. But just like with exponents, you have specific names for an exponent of 3. What is it? You have a specific name for an exponent of 2. Squared. But that doesn't mean they're not exponents. They just have specific names. So with polynomials, you have specific names for a polynomial if it has 1, 2, or 3 terms, okay? A polynomial is classified by the number of terms. And always remember your terms are separated either by a plus or a minus sign. Your plus and minus sign separates your groups of numbers and letters, okay? So, if that expression specifically has 1 term, what is the prefix for 1? No. First is a word for the number 1, but a prefix. Prefix, you attach that word in front of another word.
Oh, mono. Yeah, it means one.
The prefix monomial. Okay? So, examples of monomials would be like having just a 3x written down. Or you could have just a 5 written down. Or you could have 2x to the power of 4. But as long as it's just one term. All right? Now, what is the prefix for 2?
Oh, binomial.
Bi. Think bicycle. 2 wheels. Binomial.
2 wheels.
Okay? So an example of this would be 2x plus 3, where you have two terms separated by that plus sign. And then, what is the prefix for 3?
Trinomial.
Tricycle, 3 wheels. So an example would be x squared minus 6x plus 10. You have 3 groups of numbers separated by a plus and a minus sign in this one, okay? But, once again, they're still polynomials. Anything other than 1, 2, or 3, anything other than those specific names, so like 4 or more, you're just going to refer them as polynomials. Poly means multiple, okay? Poly means multiple.
Multiple.
All right. So, for this chart that we're going to fill out, we're going to state whether it is a polynomial, yes or no. Write the degree and then classify it, meaning these are the classifications right here, okay? All right, number 1. Is this a polynomial, yes or no? Yeah, just like what we did in the front. There is no variable in the denominator, so yes. What is the degree? 2. The highest exponent is 2. Now, specifically, what type of polynomial is it? Trinomial, because there are 3 terms. Trinomial. Okay. 1, 2, 3. Look at the next one. Would this be a polynomial, yes or no?
No.
Why not?
Negative exponent.
We have a negative exponent, so that means that technically that would be a variable in the denominator. So this is no. Okay? You don't fill out the rest of it. What about the next one?
Yes.
Yeah. What is the degree?
1.
Correct. If a variable doesn't have an exponent, that means that the exponent is a 1. Now, what kind of polynomial is it? Binomial. Okay. What about the next one? Yeah. A constant can be a polynomial. Trick question, what would the degree be?
Well, actually. Oh my God, right.
0. Let's look at the difference. When you have a variable without an exponent, you put a 1. But here, there are no variables. So having no variables is like having a variable to the power of 0. Okay? Which means that the degree is 0. All right. What type of polynomial is it? It's a monomial. And the last one? No. You cannot have a variable in the denominator. But because I got several questions on the assignment, I'm going to give you one more example. Okay? Write this down. All right. Is this a polynomial, yes or no? Yeah.
Yeah.
What is the degree? 5. What's the classification?
Polynomial.
it's just a polynomial. Anything that's not 1, 2, or 3 terms is just a polynomial. All right. For the hard part of the lesson, distributing. And it's really not that bad, honestly. Distributing. Polynomials can often be simplified distributing a monomial across the polynomial. Use the following steps. So let's say, for example, we're going to multiply 2x times 3x plus 5. Okay? Just a random example. You have a term in front of the parentheses letting you know that you must distribute. You must multiply, right? When you do that, say we're multiplying this 2x and the 3x, what you're actually multiplying is the 2 times the 3, which is 6. So we're multiplying the coefficients. Focus. But what else are you multiplying? X times x. Okay? Think back to your exponent rules. Both of those x's have a exponent of. What do you do with those? Add them. So it would give you 6x squared. Sorry, let me do it this way. Okay? So even though you multiply the coefficient, you add the exponent. Okay? Your variables will stay the same. The second thing that you would multiply in this example would be the 2x to the 5. Oops. There, 2x to the 5. So 2 times 5 is 10. The 2 has an x, but 5 doesn't. So what would you do with that x? Just bring it down. So your final expression would be 6x squared plus 10x. Now, distributing a monomial across a polynomial can also be demonstrated using area models, using those boxes. So that's what we're going to do with these first two examples. Notice we're going to distribute this 6x to the 3x, to the negative 3x, and to the negative 4. Got it? So for the first box represents that we're multiplying 6x times negative 3x. You multiply the coefficients, which is 6 times negative 3, negative 18. And then x times x, x squared. The second box represents us multiplying 6x times negative 4. So the first thing is 6 times negative 4 is x. 6 has an x, but 4 doesn't. So what do you do with the x? Bring it down. This time we're distributing a monomial across a trinomial. So go ahead and draw your box and make sure it's split into 3. Okay. Everybody got your boxes drawn? All right. So for the first box, what are we multiplying? Negative 7 times. And negative 7 times negative 1?
7.
Positive 7. We also have an x squared that doesn't get multiplied by anything, so bring it down. Next box is negative 7 times 8x. So negative 7 times 8.
32, negative 52.
Uh-huh. There's only one x in that whole thing, so bring it down. And last, we're multiplying negative 7 times negative 2, which gives you a positive 14. Question so far?
No, man.
All right. Now let's try doing the same thing, but without those boxes, without that crutch, right? So we're going to multiply first. 4 times 12 is?
48.
Bring down the?
X squared.
Then we multiply 4 times what? To get us?
28.
Bring down the x. And then we multiply 4 times? Which is?
-4.
Correct. Notice you have this 3x squared over here to the side on the outside of the parentheses. So remember, 4 does not jump over the parentheses over there. Bring it down. Now, does anybody notice something about this expression? First, you distribute. What can I do with this expression to make it smaller? Yeah, combine what? Not all of them. What can you combine? Not all the x's. You can combine your x squares. Remember, when you add, you can only add your like terms. You can only add the x's that have the same exponent. So 48 plus 3 is? Bring everything else down. 28x minus 4. Focus, boys. Y'all chit-chatting more than some of my girls. All right, number 2. Notice you have a 5x squared here in the very front that isn't in front of the parentheses, so we're not going to distribute it. We're not going to multiply. We're not going to add it, do anything with it, so bring it down. Distribute the negative 3/4. When we multiply negative 3/4 times 24x, what do you get? Sebastian, get up!
Oh, man. You did. Negative 32. Oh, I got it.
Negative 3/4 times negative 40. What's negative 3/4 times negative 40, guys?
Negative 30.
30.
I got
2 negatives make a positive.
Oh, I forgot to put the negative.
Bring down the x squared. Okay? Now, what can we combine?
5x squared and x squared.
So when we combine those, what do we get?
6x.
Now, by this point, I always have a couple of students that are a little confused because they're asking, why did we not add the x squared and the x squared? Those are 2 separate rules, okay? So when you distribute, you add the exponent because you're multiplying. Those are your exponent rules. So you add the exponent in this step. You add the exponents when distributing, okay? When you're combining like terms, only add your coefficients. Okay? So with this one, the only thing we added was the 5 and the 1 to get a 6. You don't add 2 plus 2 to get 4. Not in that second step. Got it? Yes? No? Maybe?
Yeah.
All right.